Welcome back. So we just got done talking about numbers. We wanted to make sure we could put our numbers in our calculators correctly. We wanted to make sure we could do the algebraic manipulations on them correctly. But it turns out the numbers are not the important things in chemistry. Units are the important things in chemistry. And that's a really hard thing for most people to understand, that the answer, the numerical answer of 12.7 is actually not the important part. The important part is, what do you put after that 12.7? So the first thing is, what is a unit? Think about it for a second. It's not a concept that most of us can define fairly well. What is a unit? You might be familiar with some units. You might say, well, meters is a unit, and it's how I measure something. That's an answer I hear often. It's what I used to measure. And some people say, oh, it's the units I use to measure. But you can't use units when you're defining units. So what is a unit? And probably the easiest way to think about it is an example without units. If I walk up to you and say, excuse me, do you happen to have 3? You would probably pause and think that's an odd question. And then you might ask, 3 of what? And that's what a unit is. A unit is the of what. And if you don't get the of what correctly, then it doesn't really matter what you do. So if someone walks up to you and says, excuse me, do you have 3 M&Ms? And you give them 3 kittens, you got the number right, but you got the unit wrong. And that makes all the difference in the world. If someone walks up to you and asks for 3 M&Ms and you give them 4 M&Ms, the world's probably not all that bad. You got the unit right. But if they walk up asking for A and you give them B, these two entirely different things, then it doesn't matter how many you give them, it's not the right thing. And it turns out that's how we have to think about units in chemistry as well, is they are the important things. They are the right things. So what are units? They are the what of what we're talking about. We can't just say, oh, I measured 3. I measured 3 centimeters. I measured 3 meters. I measured 3 kilometers. Very different measurements, meaning entirely different scales of things, not just 3. Just like if you're doing clinical work, you don't just write down that the head circumference was 12. You write down the head circumference was 12 inches or whatever it was. I don't remember what normal head circumference is here, so I might have gone a little bit off there. But it's really important that we have the units. And in fact, what we're going to find is that when we're doing all the work in this class, we're going to focus on the units first and make sure we get the units right, so that when someone asks for M&Ms, we give them M&Ms and we don't give them kittens. And then we're going to figure out how many of those M&Ms do we get. But we know we've got M&Ms. So they're the what, and we care because that's how we get the problem right. We can't get the problem right if the units are wrong. It's important to know some basic units of measurement. Most other units of measurement are actually built off of these ones. We're going to use the metric or SI system in this class because that is the unit of science. So while in the US we often use feet to measure things, we use degrees Fahrenheit to measure things, we're not going to use that in this class. We're going to use what's called the metric system, or sometimes the SI system, Système International, and that's going to be our primary units. So when we measure the length of things, although we will occasionally use inches and feet just for practice and conversions, if we were in the lab and we measured something, we'd measure something in some sort of metric unit. The basic unit of measurement in metric unit is the meter for measuring things, but oftentimes we'll measure things in centimeters or millimeters, and we'll learn what that milli and centi means as we go through the class. So a meter, often abbreviated m, lowercase m. What is a meter? Well, a meter is about a yard. It's about 3 feet if you're trying to do it. So if you've got a 6-foot tall person, it's half that person. If you've got a toddler, 4 years old or so, 3 years old or so, they're probably about 3 feet tall. Volume. How do we measure volume? Well, the primary unit we use for measuring volume is the liter, and it's abbreviated with a capital L. Now, you will see people use a lowercase l. They're wrong, because it's actually officially a capital L. But you do see it quite a lot. But in my class, please make sure you're using a capital L. How much is a liter? It's half a 2-liter bottle. It's probably about the best example I can give. A gallon is about 4 liters, 3.75 liters. And so it's about a quarter gallon, which is a quart. So a liter and a quart are roughly similar, although not exact. Unit of mass, the SI unit is officially the kilogram, but in chemistry, we're generally dealing with smaller quantities in the lab, and so we're going to use the gram, abbreviated with a lowercase g. And what is a gram? Well, it's about the mass of maybe a paperclip. It's a very small amount, so when we start to pile things on, we're going to get many, many grams when we do measurements in the lab. Temperature. What you're probably most familiar with is degrees Fahrenheit if you're from this country and raised in this country, because that's about all anybody talks about. I had the opportunity to live in New Zealand for a year. All the weather reports were in degrees Celsius, and in my head, I had to sit there and do the conversions, because when they said it's 17 out, I was like, I don't know if that's warm or cold just from that number. And so I learned to do those conversions fairly well. But in a year being there, I never really got comfortable with talking about weather in degrees Celsius. In the lab, I could talk about temperatures of samples in degrees Celsius and be fairly comfortable. But for some reason, weather was a hard one for me. So degrees Celsius is going to be probably our primary unit. And we'll talk about the details of that. But we'll also find a unit called the Kelvin as we go along. And we'll figure out why we have these two different units that we use in chemistry. Time, most of us know how to measure time. The basic unit of time is the second. And it turns out if you take combinations of these units, that's most other units in the world. So even units of energy, and we're going to learn what a joule is later in the class, is a kilogram meter squared per second squared. So it's based on these other units. You don't need to know that. But it's good to realize that most units are based off of these fundamental 5 units. There's some certainly that aren't, but most are. So what unit would I use if I was measuring the volume of an object? Pause, make sure you understand this one, then we'll move forward. Hopefully you came up with a volume measurement. It's going to be in some sort of liters, and in this case it's going to be milliliters. We're not going to measure volume in grams. We're not going to measure volume in meters. It's in a length. This is important because as you take measurements in lab, I see people all the time take volume measurements and then write down grams. Well, if you took a volume measurement, you should write down a volume unit at the end. If you took a distance measurement, you should write down a distance unit at the end. So making sure we're writing down the appropriate unit, because if we have 4 cats in front of us, we don't want to write down that we have M&Ms in front of us. So here, I've got another question. I take the temperature of something in the lab. My thermometer reads 14.3. What should I write in my lab notebook? Should I write down 14.3, 14.3 degrees, 14.3 degrees Fahrenheit, 14.3 degrees Celsius, or none of the above? Pause, see if you can guess this one, and we'll move forward. Okay, I'm going to tell you the answer to this one. You might be a little surprised by it. Is none of the above. Why? Because you don't know what unit it is. You didn't say, hey, I've got a thermometer that reads in degrees Celsius and it reads 14.3, or I've got a thermometer that reads in degrees Fahrenheit and it reads 14.3. You just said, oh, I've got this thing that reads 14.3. You have to know the units of measurement before you take a measurement. How can you know what to write down in your lab notebook if you don't know that that thermometer reads in degrees Celsius? So hopefully, at the very least, you put one of these ones, and maybe you put the degrees Celsius as a preference over the degrees Fahrenheit because we're chemists and we're going to use that scale. But really, it should be none of the above. Until you figure out the units of your measuring device, don't write anything down, and then take the measurement once you understand the units of your device. All right. That was all a bit for units right now. We're going to see a whole lot of units as we go through this class. Tons and tons of different units. The important part is focus on the units, make sure we get those right, because if we don't get those right, the problem can't be right. Thanks.